Hello everyone, welcome to the solution of LeetCode problem 84 named largest rectangle in histogram. In this problem, we are given an array of integers which represents the histogram's bar height where the width of the bar is 1 and we have to return the largest rectangle in the histogram and its area. Now, suppose let's consider this histogram. Here, the height of the first bar is 2, the height of the second bar is 1, then 5, 6, 2, and 3. Okay. Now, if we take this portion of the rectangle, then here the height is 5 and the width is 2. So, this is the largest area we can make. That's why we have to return 10 here. I hope you understood the problem statement. Now let's move on to the algorithm and let's see how can we find the area of the largest rectangle in the given histogram. Before proceeding to the solution, let's understand some of the concepts. Suppose our histogram is looking like this. Now, here we can see that we cannot move forward from the first bar because there is no supporting bar here. But we can move forward of the second bar. Now, what is the basic intuition? So here, the basic intuition is if suppose for this bar 2, as we cannot move in the right direction because we don't have any of the supporting bar here. So here, the area this bar 2 can make is within this range, which is 2 multiplied by 1, so where the area is 2. But for this element 1, we can move to the right side. But wait, because as this element 1 can be extended in the left side, so the area we can make is this, which is here the width is 2 and the height is 1, so here the area is also 2. So this is one possible condition. Now let's look at these scenarios. Here the bar are increasing gradually. So here we can extend the bar 1 into the right side because it has necessary amount of support here for this within this second bar. And here we can also extend the bar of the height 2 into the right side. Now here the area is, we can make that is 2, which is this portion, and 2, which is this portion. So far so good. Now what if our bars are equal, right? So here, if the bars are equal, that means we can move to the right side no matter what. So here, the total area we can make will be 4, which is this portion 2, which is width, multiplied by the height. So here height is also 2. So it will become 4. Now let's take these scenarios. Here, in this portion, the bar is increasing, but here the bar is decreasing. Okay, now suppose for this bar which has height 4, we cannot extend it into the right side. So here we can calculate the range of this bar 4. So here the range of this bar 4 will be this, and here the area will be 4 multiplied by 1, which is 4. Now here, as we cannot proceed or we cannot extend the bar 4 into the right side, so we have to pop this bar. So far, so good. So now we have popped this bar. Now here, again, for this bar, which has the height 3, we can move it to the right side, but we cannot move it to the right side or extend it to the right side further. Why? Because there is no supporting element here. So we can extend it and get the area into this portion. So here, the area we can make is 2 multiplied by 3, which is 6, which is this area. Now, but for these 2, we can extend it into the right side, so no matter what. But before that, while we are proceeding the bar 3, as we cannot extend it infinitely into the right side, we have to simply pop it or remove it from the consideration. Now, suppose, let's take this example. Here, the bar is increasing into this position and the bar is decreasing into this position. Now, we cannot consider or we cannot extend the 4 further to the right side because it does not have any of the support here. So here, the range for this 4 will be in this position. So the area will be 4 multiplied by 1, which is 4. Now, we cannot extend the height 3 further because it does not have any of the height here. But before that, as we did not able to process the bar 4, we have to simply remove it. Now, for this bar 3, we also cannot process it, or we also cannot extend it into the right side infinitely. That's why we have to first determine its range. So here the range is this portion, which is 2 with 2. And the calculated area will be 3 multiplied by 2, which is 6. So here the area will be this position. After that, we have to remove the bar 3 from the consideration. Now, for this bar 2, we also cannot extend it into the right side further. So we have to remove it. Now, we have to calculate the area. So the area it will cover will be this region here. The width will be 3 and the height will be 2. So the total area will be 6. And this example is exactly similar. So now let's understand some of the concept. As we have seen that we are removing the element from the most recent. Suppose when in the iteration we are at this bar 1, we are removing the element 4, 3, and 2, which is the most recent of the element 1. So here, if we remove the element from the most recent, we have to use the stack data structure to solve this problem. Now, let's try to understand how can we solve this problem by using the stack data structure. Suppose here, let's take another example. Now, the height of the first bar is 2. The height of the second bar is 1. The height of the third bar is 5. The height of the next bar is 4. And it is 2. And it is 3. Okay. Now, we are using a stack, and each of the element of the stack will contain two values. One is the height, another is the index. And this is the max area variable. Now, currently, suppose we are at this position, which has the height 2. So here, we have to add the height 2 along with the index number, which is 0. Okay. Now, we are at this element where the height is 1. But wait, we have to check whether the top element of the stack is greater than of this current element or not. So here we can see that the top element of the stack has the height of 2 and our current element height is 1. So obviously 2 is greater than 1. That means we cannot extend the element 2 into the right side any further. Okay. So that's why we have to calculate this area. So here the total area will be 2 multiplied by 1, which is 2. And we have to remove these 2 from the consideration. So here we are removing the element 2 and 0. Now we have to add the element 1 along with the index. But what will be the index? Now, index for this element 1 will be 0. I will explain it why. Because we can extend the element 1 into the left side. And we can get the range or the width of the corresponding rectangle into this portion. So here we can say that the starting position of this index or this element 1, which has the index number 0. Now, so far so good. Now here we are at this element 5. We have to check whether the top element height of the stack is greater than 5 or not. But here the height is 1, which is less than 5. So we don't have to do anything here. So we have to simply add the 5 into the stack along with the index number. So here the index number will be 2. Now we are at this element 6. Again, 6 is greater than 5, so we don't have to do anything here. We can simply extend it into the right side. So we have to add 6 along with this real index number, which is 3. Now, for this element 2, the real interesting thing happens. We have to check whether the height of the stack top element is greater than 2 or not. Yes, it is, because 6 is greater than 2. That means we cannot extend 6 to the right side because we are not having any of the support here. So we have to remove 6 from the current position. So here the width will be 1 and the height will be 6. So the calculated area will be 6, which is greater than 2. So till now the max area is 6. Now, as we have processed 6, we have to remove 6 from the stack. Now here again we have seen that the top element of the stack is 5, which is greater than 2. So here we can make the area into this position, which is 5 multiplied by 2, that means 10, which is definitely greater than 6. So the max area will be 10. Now, as we have processed the element 5, we have to remove it from the stack. Now, the stack top element is 1, which is less than 2. So no problem here at all. So here we have to add 2 into the current stack. But what will be the index position of 2? The index position of 2 will be 2 because for this element 2, we have able to pop this element and this element, and the range starts from here. So the index will be 2. Now again, for this 3, the top element is smaller, so we have to simply add it along with the corresponding index number of 3, which is 5. Now we have completed the iteration, but wait, we still have some of the leftover element into the stack. And what can we do with this stack element? We can simply do some of the operations. And here we can see that the stack first element is 3, then 2, then 1. We have along with the index number 5. Now for this element 3, we can make the rectangle into the right direction, which is this. That means 3 multiplied by 1. So it is one of the rectangle. So here we have to remove it. Now for this element 2, we can find the rectangle into this portion. So which is 2 multiplied by 2, that means 4. So the area will be 4. And we have to remove 2 from the corresponding stack. Now we have element 1. So here the index number of 1 will be 0. That means we can make this entire position of the rectangle and calculate its area. So here the area will be 6 multiplied by 1, which is 6. And none of them is greater than our max area of 10. So here till now, or after the calculation, the area or the max area will become 10. And after that, we have to simply remove the stack element. Now our stack has become empty and we have calculated the max area is 10. That means our max area is into these positions, which is 5 multiplied by 2. I hope you understood the algorithm. Now let's move on to the code. Here, the code is pretty simple. At first, we are given a function named largest rectangle area with the height of the each pair. Now here, we are using a stack of pairs. Now initializing the answer variable with 0 and n will store the size of the given vector. Now we have to run a loop from 0 to n, and currently our start position is I, and we have to repetitively check whether the top element is greater than our current element or not. If the top element of the stack is greater than our current element, that means we have to take the index and the width and calculate the height and calculate the area, which is width into height, and we have to upgrade our answer with the maximum value. After that, we have to remove the top element of the stack and assign the corresponding index to the start variable. Finally, we have to make pair with the corresponding height and the start variable and insert them into the stack. After that, if any of the leftover element present into the stack, we have to try to make rectangle by using this. So here the height will be the stack top element's height and the width will be the n minus index of the element of the stack top element. And we have to upgrade the answer by calculating the area, which is width into height, and we have to remove the top element of the stack. Finally, we have to return the answer. I hope you understood the code. Now here, the overall time complexity is big O of n because we have to iterate each of the element of the stack, and the overall space complexity is also big O of n because We are using a stack, and in the worst case, the size of the stack can be equal to the size of the input array. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.